Nearly 70% of candidates fail the McKinsey Solve assessment, mainly because they're not familiar with how it really works. In this video, we'll cover everything you need to know about the 2025 McKinsey Solve version, from its interface and structure to practical strategies that have helped our students succeed. The McKinsey Solve test is a pre-screening test used by the consulting firm McKinsey & Company. The test invitations are sent out after resume application, but before the interviews. Since the test is fully online, you can take it from home, so make sure you prepare your setup and environment to your advantage. As of 2025, McKinsey Solve consists of only 2 games, Redrock and Seawolf. There used to be a third game, Ecosystem, but most recent candidates report that it's no longer included. If your location still uses the Ecosystem test, we have a full breakdown in a separate video. You can find it linked here. Redrock is heavily math-driven, charts, statistics, and calculations. Seawolf, on the other hand, tests your logic and quick decision-making. But don't worry, we're going to walk through both of them step by step in this video. You should follow the link below to try the simulation for free and get immediate access to our courses and over 20 practice tests. And yes, re-watch this video as many times as you need while preparing. Let's begin with the Redrock game. Here, you'll move through data collection, number crunching, and finally compiling your report. The scenario places you on an island, joining a team of scientists. Your task is to help the research team by collecting data, performing calculations, writing reports, and creating visualizations. This is a direct simulation of the core tasks a consultant performs every single day. The Redrock test has 2 parts, the study and the cases, totaling between 12 and 20 questions. Of course, McKinsey would not go easy on us with their strict rules. First, time is limited. We have 35 minutes in total, so make sure you make it count and manage the time efficiently. Second, you only get 1 shot per question to submit, or I will call it one-hit wonder. You are not allowed to go back to review nor skip forward. Third, what should you expect? Math. A lot of math and charts waiting to be solved. Things like algebra, basic statistics, and all types of charts. Besides those rules, McKinsey pays to make its own test interface, which may confuse candidates a bit, but we will dive into it in this video. We recommend practicing 15 to 20 mock tests to build speed and see every question style. Check out our mock test library with simulations and math essentials in our link in the description. Alright, let's jump into the Redrock test. Here's the interface of the Redrock study task, or actually, the simulation created by our IT team. The time bar can be seen on the top of the screen here, telling you how much time you have left. Any pause symbol on the time bar, that means the current part is untimed, like the training questions. Over here, you can see our 2 parts, study and cases. The study is divided into 3 smaller stages: investigation, analysis, and report. At any moment, please feel free to pause the video so you can solve the questions on your own. The first stage is investigation, which is mainly about data collection. On the left sidebar are just headings of 1 long page, so you are free to move back and forth between them. However, notice that I cannot open analysis and report yet, so I can't know for sure how much work is ahead. The goal here is to collect only the relevant data into the research journal on the right side. If you collect irrelevant data, it may count against you. The data in white boxes are collectible. Simply click, drag, and drop them into the journal. The objectives are for the whole study, that is, a question you are supposed to answer. Hence, you should always collect this piece in your journal. Be sure to quickly skim the study information, as it contains vital formulas and background context that you should definitely include them. Coming down, you can see exhibits containing data, and again, only pick out the relevant data you need for the formulas and objective. The journal acts as a digital notepad, carrying your numbers into the next stages. You can also change the label and reorganize. Once you have done collecting and organizing as you need, you can submit the results to unlock the next phase, which is analysis. The analysis stage is where you perform your math skills. Here, you're supposed to use the collected data to formulate and calculate to find the answer to the objective. If you did forget to collect a key piece of data, you could still go back to investigation. This is the first exception to the not one step back rule. This stage tends to have 2 to 4 math questions, each containing 1 to 3 sub-questions. Let's try doing the first question, the expected number of capture attempts for each pirate ship this year. This is fairly straightforward since we know the number of attempts for each ship last year, and also that they will go up by 25% this year. McKinsey nicely provides an on-screen calculator on the right side for you. Of course, you can use a handheld calculator, but McKinsey wants to see your math process on their own calculator. Moreover, it's better than a handheld one because you can drag numbers directly from your research journal onto the blank spot or the calculator screen. Now that we're in the second question, you can clearly see I am not allowed to open question 1 again. For this question 2, we have to calculate the expected chances of black flag and red flag captures. We have enough data to calculate the current chances of each outcome, and we know how much they will change this year, so we do it like the first question. Also for this question, I want you to look at the unit being used, which is percent, and which differs from percentage point. Both terms are present in Redrock, so it's important to tell them apart. Before I submit, I realize the question demands us to express the result in percent, but I use decimals in my original calculations. I'm going to multiply the result by 100. Going to the third question, we now have to use the answers from the previous questions. Remember, some questions depend on previous answers, so one mistake can create a nasty chain reaction. Also, you can see that this time I'm dragging data from the journal instead of typing, to preserve all the decimals from the original answers. And the final question is just a simple addition. Not much to talk about here. Once you've done all the questions, you proceed to a tab called Review. You cannot go back to the analysis questions, but you can still check your answer by going back to the investigation stage and using the on-screen calculator. You should also use this part to arrange and label your collected data if necessary. If you're confident you've got everything right, you can now proceed to the final, easiest stage of the study called Report. In Report, the test gives you a few paragraphs that, if completed, would answer your original objectives. This is where you compile the answers from the previous stages. You also will be locked out of investigation and analysis. This summary stage consists of 3 questions or substages called Report, Graph Selection, and Visualization. This part is pretty straightforward, as your job is simply to drag numbers onto the blanks and choose the right conclusions. Also, notice the difference in the answer blanks, which now have the numbers 1, 2, 3 written on them. This signals that they accept manual input. On to graph selection. You are asked to choose a suitable type of chart for a certain analysis. Till now, most tests will only have 3 choices: pie chart, line chart, and bar chart. It requires you to know which chart types are suitable for which purposes. The directions tend to be specific enough for us to quickly figure out the correct options, as long as we know the basics. For this mock test, I'm seeing that the directions tell me to compare distinct variables, so I'm going to use the bar chart. In visualization, you will drag and drop numbers from the journal onto the chart to finalize the report. You can still change the type of chart and redo the visualization. So, we are done with the first level, the study. Moving on to part 2 is the cases, including 6 cases. Each of these cases is similar to one part or task of the study. The test also provides the calculator and journal only when needed. The flow of part 2 is like part 1. You have to solve cases in sequence, and there's no going back once you have submitted your answers. Again, take your time to pause the video if you need to solve the cases. Case 1 contains a calculation question, the single most popular question type in Redrock. The type of calculation shown here is the weighted average, so we take each possible repair cost, multiply them with their respective weight, or in this case, chance, sum up the results and divide that sum with the sum of all weights, which in this case is just 1, or 100%. The correct result should be 1.37. Case 2 contains a probability question. These probability questions in Redrock tend to be the basic types, namely intersection of events, union of 2 events, and complements. I'm going to use the union of 2 events formula for this one, so I'll sum up the chances of each of these 2 islands having a treasure, then minus the chance of both islands having treasures at the same time. The answer should be 55. Moving on to case 3, we see a fairly daunting chart and 3 sub-questions that explicitly require you to know basic statistics. This chart is a histogram, showing the distribution of values in a dataset. On the horizontal axis, we have the recorded values, in this case the number of ships spotted on a given day, and on the vertical axis we have frequency, in this case the number of days on which a given number of ships was spotted. The first question asks for the median of this dataset. The median is the middle number if all values in the set are arranged in an ascending order. If there are an even number of values, then the median is the two middle values summed up and divided by 2. In this case, we have 90 values in total from the 90 days. So I'm going to find the 45th and 46th values, add them up, and divide by 2. Since the histogram's already sorted, I just move left to right, adding up the frequencies until I pass the 45th and 46th values. Now, if we look at the horizontal axis, then the 45th and 46th should both be 5. So the median is 5 as well. So the correct option is larger than 4. The second question asks for the mode of this dataset. Mode is the value with the highest frequency. There can be multiple modes if they share the same frequency. If all the values have the same frequency, then there is no mode. To answer this question, we just need to look for the highest column in the histogram, which says 4 on the horizontal axis, so the mode is 4. So the correct option is equals 4. The third and final question asks for the meaning, or basically the average. Technically, you could use a calculator, but here's the shortcut. You see most columns sit to the right of 4, so the mean's also to the right, or larger than 4. So the answer, larger than 4. Case 4 is a math case again, but this time it's a formulation question. Instead of calculating, you need to collect necessary numbers into the research journal, which means it is a multiple choice question where you have to choose all of the multiple correct options. In the real test, these tend to be less common than their calculation cousins. Now, to answer this particular question, we just need to collect the number of ships captured for year Y-1. No need to collect the data for the remaining years. This is because, first, the question asks for just the additional revenue from the tactical changes from Y-1 to Y, not all of the expected growth. Second, this additional revenue is expressed as being 5 percentage points, added on top of the expected growth without the tactical changes. So, 5% of the revenue in year Y-1, not 5% of the growth. Case 5 also has a formula question, but this time you just need to choose one correct answer. This case also requires you to change these percentages by a few percentage points each. So, unlike question 2 of the analysis stage where we had to multiply, this time we use addition. For example, the share of ships R&D was originally 35% of the original budget. Now they want to decrease it by 6 percentage points. So, we just need to add minus 6 to 35, or a subtraction by 6. If it was a 6% decrease, we would have to multiply 35 with 0.94. Looking at the options, the first and the third ones use multiplications, so they are out. The second one needs parentheses to be correct. That leaves us with the fourth option. The final case is a visualization one. For these questions, you must be familiar with most of the chart types used in data analytics and read the directions carefully. The goal is to illustrate the shares of tonnage taken up by each type of goods. There are 37 types of goods, and they want us to illustrate the shares of tonnage taken up by each type of goods, or, to use the technical term, composition. Among the options, the bar chart is out immediately because it's not meant for compositions. All the 3 remaining options can display compositions. The next 2 options, the stacked bars, are great if we had multiple ships to compare, but here it's just one, the brass hind. So we're going to pick the tree map. Then we submit and end this mock test. So that's all of a Redrock session. In the real test, you will not know if you did your test right or not, except if you captured the test content and tried to do it on paper afterwards. The review screen I have here is just for our simulation, for practicing purposes. Do you think you did so well on the test? Share your thoughts on this video in the comment down below. The next challenge is the Seawolf game, which tests your strategic decision making. You are on a fictional ship called the Seawolf, going to 3 so-called sites, each contaminated with a different kind of waste. Your job is to clean them up using 3 treatments, one for each site. Each treatment consists of 3 different types of microbes. Each microbe has 3 numerical attributes and 1 binary trait, as shown in this microbe card. Each site, on the other hand, is defined by its requirements, also with 3 attributes and 2 traits. The numerical attributes come in ranges, and the 2 binary traits are either desired or undesired. The overall goal is to select 3 microbes so that Number 1, the average value of attributes falls within the required range. Number 2, at least 1 microbe has the desired trait. And number 3, none of the microbes has the undesired trait. Each treatment of each site is graded by an efficiency score, which is sometimes also called the effectiveness score. The maximum is 100%. To reach it, you must satisfy all characteristics-related criteria. Each time you fail a criterion, either of attribute or traits, the effectiveness of your treatment will be reduced by 20%. For example, if a site requires an energy of 3 to 5, and the energy average of all selected microbes is 5.33, you lose 20% here. If your treatment also doesn't satisfy the required range of other attributes, like adhesion and speed, you lose 20% more for each. So for attributes alone, you may lose up to 60%. For traits, if none of your microbes contain the desired trait, you lose 20%. The maximum deduction here is 20%, and there's no plus point for having more than one desired microbe. On the other hand, every time your microbe does contain an undesired trait, you lose 20%. You may lose up to 60% if all 3 microbes have the undesired trait. From all of the above, the minimum efficiency score is actually negative 40%. Hopefully, you won't be that bad. The efficiency score is not the only thing you will be evaluated on, though. More on this later. Within this year, McKinsey will replace the ecosystem with the Seawolf minigame, but the general game structure is still the same. As of now, the Seawolf game typically appears after the ecosystem and the Redrock game. The time limit is fixed at 30 minutes. Even if you complete the other 2 minigames early, you can't carry the remaining time over to Seawolf. Within those 30 minutes, you are free to allocate whatever amount of time between the 3 sites. All tutorials are untimed. Unlike the other minigames, time management is a real issue here as the workload is quite high, especially when you are not familiar with the interface or the flow and strategy of the game. There will be 60 decisions you have to make in just 30 minutes, so about 30 seconds each. Some decisions require multiple calculations. You have to be at a very efficient pace to keep up. In each of the sites, you will do 4 to 5 small subtasks called steps. McKinsey wants you to feel like these are baby steps toward the ultimate goal of selecting the 3 microbes for each site. But in fact, many of these steps are independent and have no carryover to the next ones. Here's the overview of all steps. Don't worry if you can't catch all of these on the first watch. Once you get your hands on the game and do a few practice rounds, things will make much more sense. Step 1. Build microbe profile. The game will ask you to pick 2 characteristics, either trait or attribute, to create a preferred profile. Actions in this step do not affect any other step. Step 2. Categorize microbes. You will be presented with 10 microbes and must decide whether to use each of them for the current site, reserve for the next site, or reject it. This step does affect step 0 of the next site, but it won't affect the next step. Step 3. Build prospect pool of 10 microbes, of which 6 are already given. To select the other 4, you will select 1 out of 3 microbes in 4 selection rounds. The prospect pool created in here will be used in the next step. Step 4. Create treatment. From the 10 prospects in Step 3, select 3 microbes to form the final treatment, as close to 100% efficiency as possible. This is the final task of the site, and it won't affect any other step or site. On the very next site, you will have a Step 0, Review Microbes. This is like a mini Step 2, where you will, again, categorize microbes into either this site or no site. Of these steps, Step 0 can only appear in Site 2 and Site 3. The remaining steps are consistently present in all 3 sites. You have to go through all these steps in chronological order. So all in all, there are 60 decisions to be made in 30 minutes, or 30 seconds per decision. If you are not prepared, this can be quite overwhelming. Now, let's dive even deeper into each step using the realistic interface of our simulation, which you can access via the link in the description. In Step 1, you will build a microbe profile by choosing 2 target characteristics out of the 5 provided. These can be either 2 attributes or 2 traits, or 1 attribute plus 1 trait. Basically, they want you to decide which characteristics you would like to focus on. The screen contains a site card on the right side with full information including 3 attributes with their required ranges and 2 traits, 1 desired and 1 undesired. The microbe profile setting panel is on the left-hand side. The interface is pretty straightforward here. Choose a characteristic by clicking on the switch. For attributes, there are also sliders for you to choose the min and max values. You have to choose 2 target characteristics. If you don't have exactly 2 switches turned on, you can't advance to the next step. You are free to change your selections as long as the result is not yet submitted. But once it is submitted, you can't go back to change your selections. Now, despite the tutorial giving the impression that setting a certain profile here will affect the microbes that appear in later steps, that's actually not true. All of the reports we've got so far say there's absolutely no carryover. If this doesn't affect the overall efficiency score, does it even matter what you choose here? Well, similar to all other mini-games in the McKinsey Solve, you will be evaluated based on a combination of both product score, aka the efficiency score in this minigame, and the process score, whatever behaviors you demonstrate throughout the process. More on this later in the video. Our strategy for this step? Choose one logic, one approach, or one methodology, and stick to it consistently throughout all three step 1 of all 3 sites. For example, my approach is to treat the carryover as if it's real and make selections that maximize my success chance. I would pick the one desired trait and the hardest to meet attribute. Specifically, pick the attribute with a narrower range or further away from the center. Don't forget to use the slider to select the attribute range as close to the required values as possible. In this step 2, you will be presented with 10 microbes, one by one, each with a microbe card of full information about attributes and traits. Your job is to decide to put them into either this site, next site, or no site at all, aka to reject it. The interface is also quite straightforward, with each of the microbe cards presented on the left one by one. The site's information will still be on the right, like in the previous step, and of course you will still have full information about the current site. However, you will only have access to a limited portion of next site's information. So again, McKinsey is testing your ability to make decisions with limited data, something a real consultant has to go through every day. The control panel is on the left side below the microbe card. As you categorize the 10 microbes, their information will show up in the middle of the screen in each of the 3 columns representing the current site, next site, or no site. Notice that within this step, you cannot go back to the previous microbe. Every time you categorize one microbe, the decision is final. Again, despite McKinsey making it seem like your decision here is going to affect the overall game, this step does not affect steps 3 and 4. Basically, no carryover in this site. The only small thing it does affect is step 0 of next site, but that step 0 will pretty much have no effect on the other steps on that site. More about that later. Like I said in step 1, my strategy here is also to stick with one logic, pretend the carryover is real and try to maximize the success chance. And to do that, the most crucial tip is to prioritize the current site. Specifically, if a microbe has even the slightest chance of being beneficial to the current site, keep it here. If a microbe has absolutely no chance of being used in the current site, consider it for the next site and repeat the same check. If a microbe has absolutely no chance for either site, and only then, you may reject it. Think of step 3 as a baby step to select the final 3 microbes in the end. Here though, you will only need to narrow down your selections to 10 prospects. 6 of the 10 will be given. You will pick the other 4 prospects. You can see that 6 prospects and their information are displayed here in this panel, and there are 4 empty slots left. To fill those slots, you will be presented with 3 candidates on the top panel of the screen. You must pick 1 out of 3 in each round. And of course, there will be 4 rounds. The game will ask for your confirmation every time you make a decision, and once confirmed, there's no going back. Unlike in previous steps, for the first time, step 3 and 4 are connected. You will see all of these 10 prospects again, so choose wisely. Here is where I usually share my tips and strategies for the step, but the methodology here is too important to be relegated to a brief mention. It deserves a proper section for itself. But let's quickly go over step 4, and we'll discuss the fit concept again. It will be much easier to grasp. In this step, you will select 3 microbes from the pool of 10 in step 3 to form the official treatment. The efficiency score will be given upon your decisions here. The interface is again quite straightforward, with the site information on the right side as usual. All 10 microbes from the pool will be presented with their data. Your selected microbes will go to the section below. You are free to add and remove microbes until you are ready to submit. This is the final step, and the game designer is more forgiving. Not that it really helps much. This is the final step of the current site, and there will be no carryover to the next site. Now let's talk strategy. The fit concept. The idea is to create a system to quickly and efficiently evaluate the fit level of a microbe to a site. There are the desired fit, neutral fit, and the unfit. On one end of the spectrum, the unfits are absolutely unusable for the particular site. For example, if the microbe has the undesired trait of the site, it's an automatic unfit. Also, if an attribute value is too far away from the attribute requirement of the site, it's also an automatic unfit. For example, if the attribute requirement range of a site is from 1 to 2, then every microbe with an attribute value of 5 or higher is unfit. Think about it. Even if you can find 2 other microbes with attribute values of 1 and 1, the average will still be 7 divided by 3 equal 2.3, which is outside of the requirement range of 1 to 2. To give a name to this, we call it the fit range. It is a range in which a microbe's attribute values have to fall within for it to fit. Like in the above example, if the site's requirement is 1 to 2, fit range is 1 to 4. If the requirement is 1 to 3, fit range is 1 to 7. That means every microbe with the attribute value higher than 7 is an automatic unfit. Requirement of 9 to 10, fit range is 7 to 10. Requirement of 8 to 10, fit range is 4 to 10, and so on. In fact, it helps to memorize this table of common requirement ranges, so in the real game, you don't even have to think or calculate. For what it's worth, you should probably print this table out. There's a link in the description for you to download a nicely formatted and printable version of this for free. There, you can also access our simulation of the Seawolf minigame. Now going back to the spectrum, any microbe with attributes values within the fit ranges is a fit one. If it has the desired trait of the site, then it's a desired fit. If it only has the neutral traits, it's a neutral fit. Quick quiz for you. If the microbe has the undesired trait, is it a desired fit or a neutral fit? Just comment below either desired fit or neutral fit. My answer key will be in the description. So, in our treatment of 3 microbes, we will need at least 1 desired fit. The rest can be neutral fit, but none can be unfit. Play a few rounds and you will find that this big and beautiful fit blueprint is very, very powerful. In most sites, more than half of the microbe candidates are unfit. You can quickly reduce the workload by half and focus on the nuances of selecting the best options from the 2 types of fit. Once you submit your selection and finish step 4, you will move to the next site, starting with step 0. You will review all microbes from step 2 of the previous site and choose to keep them here in the current site or to reject them altogether. The interface here is nearly identical to step 2, except that there's no next site. That next site you see in the previous site is now this site, and the full information of this site is now fully displayed. If you choose to keep a microbe, it will reappear in step 2 of this site, but already categorized. You won't be able to reject or send it to the next site. Other than that, your actions here will have 0 carryover to any of the future steps or sites. You can approach this step 0 in the exact same way you do with step 2, using the big and beautiful fit blueprint. It's normal and even expected that you change your microbe categorizations upon learning the full site information about requirements, so don't be afraid to treat step 0 as an independent task. So to sum up everything we talked about so far, step 1. Pick the desired trait and one attribute that seems hard to achieve, aka the one with an extreme required range, or in other words, the one with a narrow fit range. Step 2. Categorize microbes into either this site, next site, or no site using the fit blueprint and prioritize the current site. If a microbe is not unfit for this site, put it in this site. If the microbe is unfit, consider it for next site. If the microbe is not unfit for the next site, put it in the next site. If the microbe is unfit for both this site and next site, reject it. Step 3. Choose a pool of 10 microbes, of which 6 are already given. The other 4 will be selected through 4 rounds, each round with 3 candidates. For every round, eliminate the unfit right away. Those are the ones with undesired traits or an attribute outside of the fit range. Pick the desired fit right away. When there are 2 or more neutral fit candidates, prioritize those with hard attributes, i.e. those with narrow fit ranges and few microbes within those ranges. Step 4. From that pool of 10 microbes, pick the final 3 for the treatment. Again, rule out the unfit microbes. Usually there are still a few unfit microbes at this point. You will be left with about 4 to 6 microbes, and there aren't that many combinations you can try. Keep in mind that in roughly 1/3 of the cases out there, there is no 100% efficiency score treatment. Just come up with the best you can, settle for 80%, and move on. Similar to other mini-games in the McKinsey Solve, you will be scored based on a combination of product score and process score. Product score is the efficiency score of the treatment. This mainly comes from step 3 and 4. The other big part is the process score, coming from all of your interactions with the interface. Similar to other McKinsey Solve mini-games, here are some of the tips. Number 1, be consistent with your logic. At times when you have to make decisions without perfect data, don't stress over making the ultimately correct decision. Just focus on making the best decision given the data you have, using one same consistent logic. In step 1, for example, if your logic is to choose the desired trait plus one hard attribute, stick with it. If you have a slightly different logic, so be it, but stay with it through 3 sites. Number 2, avoid random clicking or trial and error. McKinsey's system penalizes inefficient exploration. Instead, you should make deliberate actions backed by a consistent logic, as we talked just before. Number 3, plan your approach. Know exactly what you are going to do and just go in there and execute. There's no time and place for thinking at that point. Playing with the simulation and getting a lot of reps before the real game is very beneficial. That's the end of both tests. Now you've seen how to think, calculate, and strategize your way through the assessment. Do you think you did so well on the test? Share your thoughts on this video in the comments down below. Thank you very much for your attention, and we at M Consulting Prep wish you the best luck to get into consulting.